Hi, so in this next video we're going to talk about intervals. And with intervals we're going to look at a couple of things here on the waveform. We're really going to look at two intervals of those three that we normally look at. We're going to look at the PR and the QRS. One that we're going to kind of ignore for now is this one called the QT. Remember, it goes from the Q to the end of the T there. So let's look at these in relation to the conduction system in the heart. Now, what does the PR represent? It represents the time it takes for conduction to pause in here. So the P is the time that it takes to go down here, and then the rest of this time here is the delay set in the AV node. So the PR is from the depolarization that comes from the SA node, the atria depolarize, and then the pause in the AV node. And this typically will last about 120 to 200 milliseconds. And if you remember, one of the small boxes on the EKG equals 40 milliseconds, so it's going to be 3 to 5 small boxes. So looking here at this EKG, I'm going to draw the lines of the small boxes because they're kind of hard to see here. We can tell how far the QT is, how big it is. So the PR. The P starts about here and it goes about 1 box, 2 box, 3 box, 4 boxes. So 4 small boxes times 40 milliseconds per box equals 160 milliseconds. So let's look again here. It's a little bit easier to see. 1 box, 2, 3, 4. Let me do that again because I didn't do it that well. So 1, 2, 3, 4. Again, 4 small boxes we see there, so 4 times 40 equals 160 milliseconds. So we already said that the interval is typically going to be 120 to 200 milliseconds. What if it's less than that or more than that? Right? What if it's less than 120 or greater than 200? We'll talk about less than 120 later on, perhaps in your M3 year. That's something called WPW. You'll see that in. But we're going to talk about the one that's greater than 200 milliseconds here. And let's look over here at an example that I've drawn. So here is a waveform, and you can see that this is going to be the PR here. So it would be 1, 2, 3, 4, 5, 6, 7. There's no boxes here, but just pretend that was 7 times 40 milliseconds equals 280 milliseconds. So you have a prolonged PR. And if you look at all of the waveforms, they are all prolonged with 7 boxes. And so 280 milliseconds. And so that's prolonged. So what's happening here? What is usually happening in that case is that you have an excessive delay here in the AV node. So we call that an AV block. And this one we call a first degree AV block. Let's go down to this one over here now. All right, so what do we see happening here? The first one might be 1, 2, 3, 4. And so that looks good. And this one is 1, 2, 3, 4, 5, 6. All right. And now this one is 1, 2, 3, 4, 5, 6, 7, 8. All right, that's getting more and more. How about this one? 1, 2, 3, 4. Oh, look. There's no QRS in this one. And then we come back to this one. 1, 2, 3, 4. All right, so what are we seeing here? So this one is going to be 160 milliseconds, which is normal. Then this one gets to 240 milliseconds, which is a little bit fast. Now this one is 320 milliseconds. And then this one we don't have. And then we come back to, again, 160 milliseconds. And so what's happening here is that this is getting longer and longer and longer, and then ultimately we drop one of the QRSs and we start over. So longer, 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 and you drop one and start over. And this one is called a second degree AV block. Again, it's happening in the AV node, and this is a second degree. And it's actually what's called a type 1 second degree block. There's 2 types, type 1 and type 2. We're only going to talk about type 1 here, but I'm going to just show you the other one. This one is it gets longer and longer until you drop one, right? So I'm going to try to exaggerate that drawing here. And now I'm going to drop one. So you get another P there. That's normal. And then again it gets longer, etc. Now what happens with the type 2 is you may have more than one P for each QRS. So it'll be a fixed ratio, like 2 to 1 or something like that. So you can see these are all going to be P's here. So P, 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 P. And then I'll just mark these QRSs with a Q. And so you can see it's always 2 to 1 in this one. We're not going to worry about that one, but we will worry about the top one, which is called a Wenke block, or a type 1 second degree AV block. So what is happening here is that something is wrong with the AV node, that it lets things through, but it just takes longer and longer, and it ultimately, at some point, it fails to let one through, and then it starts over again. And so that's what's happening with the type 1 AV block. There's something wrong with the AV node here. The type 2 second degree AV block, it's failing to let more than just one every now and then go through. Look, it's failing to let that one through, failing to let that one through, failing to let them on a regular basis through. Let's talk about the third degree AV block now. Okay, and we're going to have to do this in a different way now. First thing that you got to realize is that every cell here has a little bit of pacemaker activity, and so this thing is going to beat around somewhere between 60 and 100 beats per minute. This one might beat around 40 to 60 beats per minute, and if you have a pacemaker in here, it might beat like 30 times a minute. And so they have their own pacemaker activity. And so what's happening here? Let's do that here. So this first one shows the P waves, and let's say that that's going at let's say 70 beats per minute, right? And then what happened is the AV node is not letting anything through. Okay, so nothing is getting through. So what happens then is some cell maybe right after that is letting its other stuff go through, creating its own signal. So we have something after the AV node, or maybe at the AV node, and it's letting stuff through at maybe, let's say, 50 beats per minute. And so these two are going at different rhythms, these two pacemakers. And what you will see when you overlay these on top of each other is that there's going to be a third degree AV block, or a complete block, because nothing is getting through that AV node here. Nothing is getting through here. So this thing keeps firing, and it keeps causing P waves, but then it gets stopped here, and some other cell, maybe here, is causing the rest of the heart to depolarize. And so you get these things, which each ones march at their own rhythms. The P's, you'll notice, are equidistant from each other, and then the QRSs are equidistant from each other, but they are not at the same rhythm. This one's 70 beats per minute, this is 50 beats per minute. Okay, let's look at one more thing. What happens when the QRS gets wide? And so remember, what does this QRS represent? It represents the signal going through these bundles here, right? The His-Purkinje system. And these go really fast, and that's why you see that very fast, narrow. Fast means narrow because time is on this axis. You see this fast waveform here. But what happens if you get a block in here? Something prevents conduction from going through. Then that means in order to go around it, it needs to go around like this. And so we know that conduction is slow through here. The electrical impulse moves very slowly here because it's not going through these electrical superhighways. And so when something slows down, it widens out the QRS. And you can see here that the QRS is really wide, right? And so that's called a wide QRS. And that's usually due to some sort of delay in or block here in the His-Purkinje system, and then the conduction has to go around, and there's going to go through the muscle tissue there. And so that's what we looked at for intervals, right? There is QTC, which we are not going to talk about today, but you will talk about later. But we did talk about the PR and the QRS, right? The PR, we're going to have first degree block, second degree block, and third degree block. We know there's two types of second degree AV block. And we also talked about the QRS, where you can have a wide QRS and you can block one of these bundles. You can actually block either the right or the left bundle, and it causes difference in appearance here. Thank you. Bye.